Day 42, honors energy, problem 32. We've had problems like this before that we've done with kinematics. That's the harder way. So let's do it the easier way now, conservation of energy. So we have this ramp that's hill, it's 300 meters long, but we got to figure out how high this person is. So I've drawn my diagram here. In the lower left-hand corner, I'm looking at the triangle. If you use the sine of 5 degrees, that's equal to h over 300. So we know how high this person is, because what we're going to figure out in a few minutes here is the GPE of this person. They're starting at the top with a total mechanical energy of the kinetic energy plus the GPE. So going up over here to the top, I've calculated the kinetic energy and the GPE, which is relative to the height of 26 meters. So you have your MGH right there and your 1/2 mv squared over here. Add those together, the total mechanical energy at the top is 20,900 joules. As they slide down, if there was no friction at all, which would be low friction with the snow, but here it does say that there is some frictional resisting force, whether it's air resistance or the friction between the skis and the snow, which will be some. They've kind of combined all that to a 40 Newton frictional force, which I've indicated in the diagram with the 40 Newtons straight at the person, essentially parallel to the ramp. So at the bottom, once again with no friction, you'd still have 20,900 joules of energy. But because of frictional losses, and it's not really losses, the energy is transferred into heat. So we still have conservation of energy here. So at the bottom, we're going to have our total mechanical energy that we started with at the top, the 20,900 joules, minus our frictional losses, the work done by friction. And the work done by friction is the force of friction. It tells you it's 40 newtons times our distance. Well, you're going to be sliding along a ramp 300 meters. So as you slide down the ramp, technically that force is against you, so it is against you, parallel to the ramp, and it's transferring your mechanical energy into heat. So it's a loss. That's why I'm subtracting that. And when you do the subtraction there, it comes out to be 8,900 joules of energy left over. Well, when you get to the bottom, all that mechanical energy will be kinetic, because they'll be moving with some speed, but we have no relative height now based on ground level at the bottom of that hill, if we call that our zero level of GPE. So you just plug into the kinetic energy formula, 1/2 mv squared, solve for V, and you got it.